Okay, so this is Mr. Combs, and sorry about my voice today. I caught a little bit of a funk over the weekend. I'm not sure if it's sinuses or allergies, but I'm getting better, so that's good. I don't see anyone logged on right now, but and we've had school being canceled, and so I'm sure that I'm not sure that everyone is on the same page. So I'm going to try to, with this video and with this session, I'm going to try to talk about that a little bit, and then we're going to talk about simple interest. I'm going to get us up through HCTC spring break, which will not be next week, but the next week. So I'm not going to come to schools until after HCTC spring break. So for this week and next week and the next week, I'll not be doing a school visit. But then when I do another school visit after spring break, I'll be at Wolfe County, and then I'll be at Lee County. Anyway, so what I'm going to do today is talk to you a little bit about the schedule up until HCTC spring break. Now, if you guys are still in class during that spring break, which I think you guys are, and I know that I think the spring break for you all will be the first week of April. And if that's true, then I know I found it on the Wolfe County website. So I know that's true for Wolfe County, but if it's not true for Lee County, let me know as soon as possible. So what I want to do is share the course outline with you, and then also share my open math page for a little bit, and then talk about simple interest. Now I'm recording this, so this will be on the my open math site for anybody who doesn't log in, and for right now I'm the only person in the room, and that's okay. I know we've had a lot of school absences and we're not together, but hopefully we can rectify that today. So what I'm going to do is share my screen. Actually, I'm going to share an application with you. So I want to first talk to you about the course outline. Okay, so you should be able to see the course outline now. Let's go back to where the trouble began. This was a Monday of this week, and HCTC had classes canceled. If you look at the course outline, which you should be checking, I would go ahead and check the course outline every Monday maybe, or every week at least, to see if it's changed. But so if you're looking at the course outline, so it says that HCTC classes were canceled on Monday due to flooding and road closures. So what I said was catch up on homework not completed. You should have completed up through homework I at this point, and don't forget about the quizzes. So then for Wednesday, for today, we are going to cover simple interest. What I want you to do is take a look at homework J. Homework J is simple and compound interest, but we won't talk about compound interest until Monday. So look at homework J. You can complete questions 1 through 13, but you don't have to complete all that. And then also before Monday, watch video set 5, which will talk about compound interest part 1. It'll be an introduction. And then in class, we will talk about some applications of compound interest. So in class on Monday, you will be able to, we'll have questions over previous material if you have any, and then we'll also finish up compound interest. And then in class on Wednesday of next week, we will do annuities and loans. Now for the next week, that will be spring break. So for HCTC. So what I would like to do, because I think you guys are still in class, if I'm wrong about that, just let me know. But what I would like to happen is I would like for well, I want this to well, okay. All right, there we go. So what I want to happen is I'd like for you to catch up on all the work, so you'll have an entire week. And then I would also like for you to take test two. So I'm going to send test two um, probably after today to Mr. Wright or Miss Creech. And just like test one, you can use a calculator and one side of a sheet of 8.5 by 11 paper of notes. I put all those formulas on it because there were a lot of formulas for this chapter. And then I would like for you to have taken the test by Thursday, March 14th. You have that whole week except by Thursday, because on Friday I'm going to come and pick up test one and test two from the school. All right. So so that's how I'd like for this to go. And then we'll spend, after spring break, my spring break, we'll spend a week where we're on Blackboard Collaborate again. And then the next week I will be in Wolfe County on Wednesday. And then I think the next week is your all spring break. And then the next week I'll be in Lee County on Wednesday. Then we will have a week of hey Ashton, can you hear me? Um, I can't hear you if you're responding. Can you hear me? All right. If you can hear me, Ashton, just you can chat or you can just say hello or something. Can you hear me? Okay. So I mean, as far as I can tell, my microphone is fine. So I'll move on. So So what I was doing before you logged in is I was talking a little bit about the course outline, so I won't repeat that because I've got this video recording. So you can actually look at the course outline and also listen to the beginning part of the video when I post this later today to find out about the course outline. So this is all in myopenmath.com. So anyway, so let's now talk about, I'm going to stop sharing the course outline, and I want to start sharing the information about simple interest. Because that's what we want to talk about today. All right, so let's talk about simple interest. So this is Unit 2. Growth and finance. Now we talked about growth. Sorry. Now we're going to move over and start talking about finance. So mostly we're going to talk about we're going to talk first of all about interest, and then we're going to talk about annuities and loans, so savings accounts and loans, just a little bit of personal finance. So to understand what happens when you take out a loan or when you start a savings account, we need to first understand interest, and there are a couple kinds of interest that we're going to talk about. The first is simple interest. This is mostly this part of the chapter will mostly be using formulas. We won't create as many formulas as we did in when we talked about growth. In growth, we actually looked at information and we came up with an explicit formula. Here, most of the formulas will already be provided for us, so we won't have to come up with them. We'll just need to use those. So let's talk about simple interest. So we often find ourselves in situations where we borrow money from some lender. For example, when buying a house or a car, most of the time we take out a loan from a bank, credit union, finance company. When purchasing online, we may want to use a credit card, and using a credit card is a form of borrowing money. We are borrowing money from the credit card company, and we will pay back that money at a later date. So borrowing money is not free. Lenders often require a fee for the use of their dollars, and this fee that's charged is called interest. On the other hand, when you open a savings account at the bank, you agree to allow the bank to use your money to lend to others. So when you put money in the bank in a savings account, the bank is using that money to lend to others, and they charge other people interest, and you get a cut of that interest because the money was yours to begin with. So in this situation, the bank is the borrower and you are the lender, so the money in your account gains interest. So in some instances, interest is calculated as some percentage of the principal. So the principal is the original amount borrowed or invested. So the original amount that you borrow or the original amount that you put in the bank, that is interest. And I'm sorry, that's not interest, that's the principal. Sorry about that, that's the principal. And sometimes the interest only involves the principal or only involves the initial amount, and that type of interest is called simple interest. To figure out how much simple interest is paid when borrowing money, we use the following formula: I equals PRT. And in this case, I is the interest charged or earned. So when you use this formula, you're finding the interest. P, sometimes you'll see this labeled P sub 0, is the principal. R is the interest rate, and sometimes this will be referred to as the annual percentage rate because the interest is usually charged or added yearly. If the interest is paid in smaller time increments, the APR, or annual percentage rate will be divided up. For instance, if you earn 6% APR, then if it's paid monthly, it's going to be divided into 12.5% payments. So that's just 6% divided by 12. And then T is the time in years. So we're going to talk about how to use this formula in a few situations. So one type of loan that uses simple interest is a bond. And David Lippman, who is the author of Math and Society, one of the textbooks that we're using, says that bonds are a loan made to the bond issuer, a company or government, by you, the bond holder. In return for the loan, the issuer agrees to pay interest, often annually. Bonds have a maturity date, and the maturity date is the time that the issuer pays back the original bond. So what the idea of a bond is that a company or a government needs money. They need money right away to maybe build something or to start some kind of initiative. So they sell bonds, and what happens is they will sell you a bond, and you'll buy it maybe for $1,000 or $500 or something like that. And then when they pay you your money back, it will have gained interest. So you're lending them the money to start their initiative. And then when you cash that in after it matures, you'll actually get your money back plus interest. Sometimes we talk about, or sometimes we've heard about, like during wars, like World War II, they'll have like war bonds. The government will issue war bonds where you basically help the government to fund the materials needed to participate in the war, but then at a later date, when we are not in conflict, you'll get that money back with interest. Companies also issue bonds as well. So let's look at this situation. It says, suppose your city is building a new bank and issues bonds to raise the money to build it. You obtain a bond that pays 5% interest annually and matures in 5 years. How much interest will you earn? So notice that we're asking how much interest you earn. So we need to use the simple interest formula, I equals PRT. One of the things that I want you to recall is that to use percentages in calculations, we must convert them to decimals. So to convert a percentage to a decimal, we're going to move the decimal point 2 places to the left, and that's essentially the same thing as dividing by 100. So to solve this problem, we need to use the simple interest formula, like I said before. P is the principal, and you can look back on your sheet. That's the amount that we have invested or borrowed. So we are investing, in this case, $1,000. So P is 1,000 here. R is the rate. So the rate, if you remember, is 5%. So that's the amount of interest we're going to gain, 5% a year. And to use that in calculations, we need to convert that to 0.05. So what that is 5 with the decimal point moved 2 places over. To the left. All right, now the time. How long will it be until this bond matures? 5 years. So the time is 5. So the simple interest formula is I equals P R T. We know PRT, and now we can find I. So basically the simple interest formula will be I is equal to 1,000 times 0.05 times 5. And when I multiply all that up, I can do that using a calculator. I will get that the interest earned is $250. So the interest earned after 5 years, uh-oh, I didn't mean to do that. I didn't mean to clear. I just meant to erase. But anyway, doesn't matter. Let's do 1,000.05, and time is 5 years. So the interest is 1,000 times 0.05 times 5, and we said that that was $250. Okay. That little eraser, I have to keep remembering that it's clear and not erase just a part of what you've written. I'm still figuring that out. But anyway, so if we want to know how much you will get back total, we have to do some further addition. So if we want to know how much you will get back when the bond matures, we find the sum of the interest and the principal. So the sum of the interest and the principal will give you the total amount, which we're going to refer to as the future value. And we let the letter A represent the future value. So in this case, the future value of the loan will be the interest, which is $250, plus the original amount of the loan, which is $1,000. So 1,000 and 250 is actually $1,250. So when you cash that bond in, you'll actually get $1,250. You paid 1,000, but you'll get $1,250 for it. All right. So if we look at that idea of sum or add the interest and the principal together, this is what it might look like. A equals I plus P. But I know that PRT is equal to I, so I can substitute PRT for I to get A equals PRT plus P. Then I can factor the P out, so divide by P here, divide by P here, to get the formula A equals P times RT plus 1. And we use this formula when we need to know the future value of a loan with simple interest. So the I equals PRT gives us the amount of interest we've earned. A equals P times RT plus 1 will give us the amount that you'll get back from the loan, or the amount that the total amount you'll pay in if you've borrowed money. So A is the future value, P is the principal, R is the interest rate, and T is the time in years. So let's take a look at this one. So this one says Sue borrows $2,000 at 5% annual simple interest from her bank. How much will she pay back at the end of 5 years? So this is not asking how much interest will she pay. This is asking how much will she pay back at the end of the 5 years. So it's not asking how much interest the account has gained. It's asking how much she'll pay back. So for this one, I need to use the future value formula and not just the interest formula. So A is equal to P times RT plus 1. So in order to find the future value, I need to find or know the principal, the rate, and the time. Okay. So the principal is the original amount that you borrowed or invested. So Sue borrowed $2,000 So the principal here is $2,000. The rate is 0.05 or 5%, and the time is 5 years. So all I do is put this information into the formula and I simplify. So A is going to be equal to $2,000 times 0.05 times 5 plus 1. Now here you have to remember the order of operations. First thing I'm going to do is 0.05 times 5. I'm going to add that to 1. Then I'm going to multiply that by 2,000. And when you do that, what you're going to end up getting is $2,500. So how much will she pay back at the end of 5 years? $2,500. So basically that's it. That's the simple interest formula, and that's the future value for a simple interest account formula. So the rest of the time that we have, we're just going to look at some examples. So let's take a look at these examples. I want to do as many of these as possible, but we may not get to all of them. So let's just get started. So Margot borrows $300 and must pay it back with 6% annual interest after 11 months. How much interest will she pay? So this is asking for how much interest. So I need to use the simple interest formula. I equals PRT. The principal will be $300. That's how much she borrows. The rate will be 6%. So 0.06. Now let's think about the time. The time in this one is a little bit different. Remember, time is always given in years. Here I have an 11 months. So we have to think about what part of a month or what fraction of, what part of a year or what fraction of a year is 11 months. Well, if there are 12 months in the year, 11 months will be 11/12, right, of the year. So here this is not one whole year, it's going to be 11 months. So that's 11/12 of a year. So now that I know P, R, and T, I can put those into the formula and simplify. So 300 times the rate, 0.06, times the time, 11/12. Okay, so when I multiply that all up, and what I would do is, if you have like a graphing calculator, you just type this in exactly the way it looks and it'll simplify it for you. If you have a regular calculator, what I would do is I would say 300 times 0.06 times 11 and then divide all that by 12. So 300 times 0.06 times 11 and divide that by 12. And what I'm going to get is 1650. So how much interest does she pay if she borrows $300 for 11 months at 6% annual interest rate? Well, she pays $16.50. All right. So the next one says Ben wants to buy a used car. He has $3,000 but wants $3,500 to spend. He invests his $3,000 into an account earning 6% annual simple interest. How long will he need to leave his money in the account to accumulate $3,500? That's the $3,500 that he wants. Well, this one is dealing with the future value, right? I'm not giving anything about the interest, but I am told that we want our future value to be 3,500. So let's use the future value formula here. A equals P times RT plus 1. So here I know the future value. This is 3,500. I know the principal. That's what I'm going to invest. That's 3,000. I know the rate. That's 6%. But what I don't know is time. So my question is how long? So I'm going to actually be solving this for time. So I'm going to fill everything else in and then solve. So I know that I want to get $3,500. I'm going to put 3,000 in the bank now. The rate is going to be 0.06 times the time, I don't know what that time is, plus 1. So now all I have to do is solve this equation for C. Not C, T, I'm sorry, it's early in the morning. So solve this equation for T. So the first thing I'm going to do is I notice I have 3,000 that's multiplied by this expression that has T in it. So I'm going to divide by 3,000 on both sides. So 3,500 divided by 3,000, you could actually leave that as the fraction 7/6, or you could say that that's 1.6666. It's actually it's 1.166, and it goes on forever. So I'm going to stop after 4 or 5 decimal places. What you want to do is not round while you're working with these problems too much. Round at the end if you're dealing with money to 2 decimal places. You can round to 1 from anywhere from 1 to 3 if you're dealing with like time or something like that. But while you're working these problems, carry the decimal point out pretty far so that you don't have a rounding error. Alright, so 3,500 divided by 3,000 is 1.166666666, goes on forever. So I stopped it and rounded to 7 after a few minutes. And that's going to equal 0.06 T plus 1. So now I'm going to subtract 1 from both sides. So I have 0.167 is equal to 0.06 T. So if I divide by 0.06, I'm going to get T is equal to 2.777, I think. I'm going to say 2.78. So how long will Ben need to leave his money in the account to accumulate $3,500? He'll have to leave it almost 3 years, right? 2.78 years. All right, let's look at the next one. It says a loan company charges $30 interest for a 1-month loan of $500. Find the annual interest rate. So in this case, I'm trying to find, or I know the interest, trying to find the interest rate, but since I know the interest, I'm going to use the interest formula. I'm not going to use the future value formula. So I equals PRT. And this time I am going to solve for R. So I'm going to start out with the interest, that's $30. The principal is $500. The rate, I don't know. And the time is what? 1 month. So the time is going to be 1/12. Because it's 1 month out of 12 months, right? So it's 1 month. And so it's 1/12. So a month is a 12th of the year. Now, when I multiply 500 by 1/12, what I get is I can multiply 500 by 1 and divide by 12. I get 41.666 that goes on forever, so I'm going to say 41.6667 maybe. R. All right, now to solve for R, I'm going to divide by 41.6667 on both sides. And I'm going to get that R is equal to 0.71999 that goes on forever. So that's a decimal, but the annual interest rate is a percentage. So to change that from a decimal back to a percent, I'm going to move the decimal point 2 places, and I'm going to say that's 71.9%, or you could even say approximately 72%. So that is a very high interest rate, right? And companies, you might think, well, $30 is not so much to pay back if you borrow 500, but that's 72% interest rate. So all right, let's look at the last one, and I think we'll be able to cover this by the time it's time to end our session. So this is Melanie, and Melanie invests a total of $25,000 in 2 accounts paying 8% and 2% simple interest, respectively. How much was invested in each account if after 1 year the total interest charged, or I'm sorry, the total interest earned from both accounts was $590? So in this case, I know that I'm going to be investing some money at 8% interest, and I know that I'm going to be investing some money at 2% interest. So I don't know, however, how much I'm going to put in each account. So the technique that I'm going to use here is I'm going to say I'm going to put X dollars in the first account. I know how much money I have total. I have $25,000 total. So if I put X in the first amount, then I'm going to have to put whatever's left over, or $25,000 minus X in the second account. All right. So since I know the interest, I'm trying to fill out IEPRT, and I have two instances of the simple interest formula here. I know that it was 1 year, right? So both of these are in there for 1 year, so T is 1 in both cases. Here the interest rate is 8% or 0.08. And here the interest rate is 2% or 0.02. So if I multiply these up, and I multiply these up, and I add them together, I should get the 590, right? So I'm going to stop sharing this so I can have a place to write, and I'm going to start sharing a whiteboard just so we can finish this out. All right, so in account 1, I have so if I'm dealing with I equals PRT, in account 1 I have the principal X, and I'm multiplying that by 0.8%, and then I multiply that by 1. So that gives me 0.08 X. I'm going to add that to the principal of the next account is, I'm not sure what it is, but I know that it has to be $25,000 minus whatever I put in the first account. So that's X. The interest rate here is 2%, so I'm going to multiply this by 0.02, and I'm going to multiply it by 1 for 1 year. Now, these are the two expressions that will tell me the interest that I earned for each account. If I add them together, then I should get 590, because that's how much interest I earned for both accounts. So now all I have to do is solve this equation. So this is going to be 0.08x plus 0.02 times 25,000 will give me 500, and then I'm going to subtract 0.02x. So all I did there was I took this 0.02 and multiplied it by 25,000 and multiplied it by x, so I just used the distributive property. Alright, so when I do that, that should equal 590. I can combine like terms, 0.08x minus 0.02, that's going to give me 0.06 plus 500. Equals 590. If I subtract 500 from both sides, I get 0.06x, is equal to just 90. And if I divide both sides by 0.06, I'm going to get x is equal to 1,500. So, Melanie invested, 1,500 at 8%. So 1,500 at 8%. And then whatever 25,000 minus 1,500 is, that's 23,500. That's what she invested at 2%. All right, so those were some problems dealing with simple interest, what I'd like for you to do now is take a look at the homework dealing with simple interest and compound interest. You can do 1 through 13. Also take a look at the compound interest part 1. There's a video in my Open Math video set, and then there are, you can finish up the homework on simple interest and compound interest. Well, actually, no, you can't, because what we're going to do is we're going to continue to talk about compound interest next time. So after next time, you can finish up that homework. Then try to catch up. We're going to talk about loans and annuities, and you're going to take the second test. So make sure you take a look at the course outline, and I guess we'll close this session down a little bit early. It's 10:01, not quite 10:06. But just let me know if you have any questions.